All right, so far we've been looking at different displays for distributions, so different types of graphs. We've been looking at a bar graph, we were looking at histogram, we were looking at dot plots and also stem and leaf plots. And those dot plots could be also turned into sort of like a bar charts if we were, or histograms if we were to extend um, bars like this. So it sort of reminds us of a bar chart or a histogram. Stem and leaf plot is also similar if we turn it around and we do the bars this way. It also uh, will remind us of that bar graph or histogram. Why are we doing that? Well, we need to display the data because we want to learn about the characteristic of our distribution. So the main characteristics of our distribution for as far as quantitative data is concerned is the shape, outlier, center, and spread. So let's talk about those. So I got this graph. This is basically experimental data that was recorded and now it's displayed. What was happening in this experiment, a group of people were throwing two dice together, and they basically added the numbers for two dice that they rolled out, and they recorded how many times they got each number. So and then they displayed. So it looks like seven. So what can we get from this graph? Let's see. So first of all, we can see that the mode or the number that they got the most was 7. Now, so this was the most frequent occurrence. So we could conclude that rolling a 7 is more likely to happen. Also, not only that, but what about the numbers next to 7? What about 8 or 6? Are they also likely to happen, and how likely are they to happen in comparison to 7? What are the least likely numbers to roll? And according to this data set, it looks like 2 is the least common number. 12 follows it, but it still happened a little bit more often than 2. Okay, also the question is, how spread is our data? Did we always roll only 7s, 6, 8s, 5s, and 9s? Or did other numbers happen? If they happen, are they unusual or are they usual? So this is so how spread was the data? What was the least number that was rolled? What was the largest number that was rolled? What's the range of this data? So these are the types of questions that we will look into by looking at the graphs. All right, here's another display. This is the exam 1 scores for fall 2019 hybrid math class. So basically what we're wondering is what's the shape of this data? Is there, for now, we're just looking at what's unusual about this data. Well, we can look at it and say, okay, the most common score for this exam was between 70 and 80. We don't know exactly what the scores were, but the most common score was between 70 and 80. That we know. Also, a lot of people got scores, majority of the class got scores of 60 and up. Okay, but then we have a big gap. We have kind of like a second peak going on right here. right? So, and that's for the scores between 30 and 40. This was a common score. It was not as common as between 70 and 80, or even between 80 and 90. That was still most more common, but the next common was between 30 and 40. And then what was the spread of the data? Well, we had some, actually, there is one person who got between 0 and 20. So this is the takeaway from the shape of this data, and we're going to be talking more about shape in a minute. So are there any outliers? Okay, so mode from 80 to 90. All right. Majority got a score higher than 60. Okay, what about the outliers? Outliers, if you remember, those are unusual scores for the data set. So this one score between 0 and 20 would be considered unusual, since the majority of the class actually got greater than 60. Then getting a 0 is unusual. So yes, there is an outlier. One score of, we don't know exactly what the person got. Well, actually, I know exactly what the person got. The person did not show up. That's why they got a 0, actually. But from the graph, we don't know that. So from 0 to 20. And what is the center? Well, the center is the mode that we already mentioned about. And what is the spread? Well, the spread was from 0 to 110 is what it looks like. Okay, so this is what we can get from this graph. But there is more. There is more that we could talk about in terms of shape of the distribution. So one thing that we can talk about is the mode. So mode is basically the most frequently occurring value. So, and it results in a higher bar, right, for the frequency display. So if we have a distribution that has only one bump like this, we're going to say it's a unimodal distribution. It has one mode. And then if it has two bumps like this, then it's going to be a bimodal distribution. And then when we don't have like any pronounced peaks, even though yes, this bar is taller than the rest of the bars, the tallest one. And technically, if I ask you for the mode, you are gonna say that this is the mode of the distribution, but actually, like, all of the other bars are pretty close to it. So it's nowhere close to this distribution. So no distribution is perfect. You're not gonna have a distribution where each bar is the same height. It's just not realistic. So if they're approximately the same height, then this type of distribution is called actually a uniform distribution. A uniform distribution. So what kind of, so the bimodal distribution would usually come up when you combine two different population with two different modes, two different peaks. For example, if we combine the heights of men and heights of women. Usually men have heights, the average height higher than women, but if we combine, we could get a bimodal distribution. The uniform distribution would be when we had classes online, and let's say not online, I'm sorry, on campus, and let's say that I would record the time for each class that I had, then they would pretty much come up very close, right, to each other, and that would result in a uniform distribution. Another thing that we could be talking about in terms of the shape is symmetricity of the shape. How symmetric is the distribution? So like this distribution, we see that it is symmetric, meaning the left side of it is kind of a mirror image of the right side. So this distribution is pretty symmetric, where this distribution is not symmetric. The majority of the data is on one side. It's lopsided, or basically the statistical term is skewed, and this distribution is skewed to the right, and we're going toward in the direction of the tail. So if it has a tail on the right, we're going to say that this distribution is skewed to the right. I know it's counterintuitive, so watch out for that. This is skewed to the right or positively skewed. And if we have a distribution that has a longer tail on the left side, then we're going to say that it's negatively skewed or skewed to the left. Some other features to look in a distribution is whether it has any gaps, or those are spaces that separating data. So like here we have a gap, and also outliers. And outliers are the data values that are set far apart from the rest of the body of the distribution. So like this value right here would be an outlier. Now let's talk about some special shapes that we're going to be talking about in this class a lot. Probably the one that we're going to be talking the most about is the normal distribution. What is a normal distribution? Well, the normal distribution is defined like that. It's unimodal, so it has only one mode. It's not bimodal or multimodal. It's symmetric and bell-shaped. Okay, so if we see a distribution like that, we're going to say it's approximately normal. So unimodal, and then bell-shaped means the frequencies start low, and then they peak around the center, and then they go low again, like this, creating a bell shape. So this is a bell-shaped distribution. And majority for the bell-shaped distribution, or approximately normal distribution, the majority of the data will be located in the center, around the center. And it's because it's symmetric, it's not skewed to the left or skewed to the right. It's the mode is exactly in the center, and the mode will coincide, be very close to the mean of the distribution as well. Another shape that that's noteworthy is the uniform distribution, and that's the distribution that looks like this. Is the distribution is flat across the top. We say it's uniform, so like that. Now that you know vocabulary that associated with describing shapes of the distribution, let's try this exercise. So I want you to pause and hear and describe this distribution, and then we're going to continue together. So remember that when describing the shape of the distribution, you're going to have a focus on the three aspects. You're going to describe the center of the distribution. You're going to focus on the spread of the distribution, and then and the shape. And in the shape, you're going to focus on three aspects. So the mode is the first one, and then the spread of the distribution and the unusual features. Those would be your gaps, outliers. Yeah. Okay, so pause here and try to think about how would you answer those questions. And I'm going to continue. So as far as the center of the data, when you're looking at a histogram like that, I want you to focus on the mode. And the mode would be the tallest bar here. And it looks like the tallest bar here is from 50, so this is 60, from 50 to, this is 60, yeah, 55. So the center would be from 50 to 55. And by the way, I forgot to read the question. It says, a meteorological station in Hawaii has gathered the following average daily wind speeds over 43 days. In the following histogram, these average speeds are displayed. So we have speeds for winds in Hawaii. And it looks like the most, wind speed that happens most frequently is between 50 and 55 miles per hour. Okay, now the spread. What is the spread of this data? Well, we have the lowest value is right here from 0. So it's from 0 we have to 5. And then there is a gap. So and then we start again with 15 and over about 70. Okay, so that's the spread. Now let's talk about the shape of the distribution, or, well, we talked about the center or mode. And is this a unimodal or bimodal distribution? And if you said bimodal, you wouldn't be docked. However, I would say that it's a unimodal distribution, because it's if we chopped off this piece of this bar and put it here, it would definitely be the unimodal distribution. Right, so one bar will not make a difference. It would be a bimodal if we had a bunch of bars here and then another bunch here that would stick out. Then it would be a bimodal distribution, but for this one, I would say that it's a unimodal. But if you said bimodal, I would not dock you. But this is a unimodal distribution. Okay, so what other thing that we can say about the shape? Is this symmetric? So mode, is it symmetric? Well, this is definitely not symmetric, right? It has a longer tail on the left, and so for this one, you would have to tell me that it is skewed, and don't just tell me that it's skewed. You have to tell me that it's negatively skewed or skewed to the left. Okay, and the last thing that we want to discuss is some unusual observations or unusual features of this distribution. Well, there is a gap here. Seems like there were no winds from 5 to 15 miles per hour, and there was one outlier, 0 to 5. And the reason we want to note that is in case of maybe this is a very unusual value for this distribution. So we could say, oh, maybe something happened and our equipment failed on this day. So, or maybe if we checked the equipment and decided, yes, our equipment was working and it was unusually calm day, then we would include it in the data. But if it was due to equipment failure, then we would throw this value out in the computing. All right, so this is it for this video, and I'll see you in the next one.